All right, now that you've seen the video on oxidation numbers, now we're going to talk about where we use them. We use oxidation numbers when we talk about reduction oxidation reactions, or redox reactions for short. All right? Essentially what a redox reaction is, it's a transfer of an electron. Now, these reactions have become increasingly more important as more and more things use batteries. Batteries are chemical reactions, but we're transferring electrons across a wire when we do that. And so this type of reaction has become extremely important, all right? So let's define oxidation and reduction. Oxidation is the loss of electron. So if you say something is oxidized, it has lost an electron, all right? Now it's possible that something that's oxidized has lost 2 electrons or 3 electrons. The whole point here is if something's oxidized, it has lost electrons. Reduction is the gain of electrons, and the name should make sense because if an atom or anything gains an electron, then that charge is reduced, right? So you have chlorine. If chlorine gains 1 electron, its charge is then -1, its charge has been reduced, all right? One thing that I remember from my high school chemistry class, and I don't know why, is this acronym oil rig. Oxidation is loss, reduction is gain, all right? So if you can't really remember what's going on with oxidation and reduction, oil rig. There are several other things out there that you could use to remember it, but this is the one I use. I'm not sure why that one's stuck. Anyways, there's 4 types of reduction oxidation reactions that we're going to talk about. Combination, decomposition, combustion, and single displacement or single replacement. It's the same reaction, there's just 2 different words used to describe the same thing. Don't know why they exist, but that's what we have here, all right? So, what does it mean to combine things? If we have a combination reaction, what we get are 2 or more things making 1. So we have 2 or more compounds or substances getting together and forming 1, all right? That's what a combination is. If you combine 2 things, you take 2 things, put them together, and make 1. Combination. Decomposition. Decomposition is when 1 becomes 2 or more. So in this particular case, we have 1 substance breaking down or decomposing into 2 or more things. Is it possible for 1 compound to break down and make 3 things? Absolutely. Absolutely. Normally though, it's 1 compound breaking down into 2. All right? Combustion. Probably should have wrote combustion in red. Combustion, this is very specific. It's when a compound with carbon and hydrogen reacts with O2, all right? Essentially what this is when something's burning, all right? Everything that you burn has carbon and hydrogen in it, and it reacts with oxygen. It needs that oxygen to burn. You know this because if you've ever put out a candle with like a cup or anything like that, you're cutting off the oxygen supply. I put CX and HY here because it doesn't matter how many carbons or hydrogens you have, the reaction still goes forward. And lastly, we have single displacement or single replacement. I will be saying displacement. This single displacement reaction, it's when 1 element displaces an element in a compound. All right? So we have these 4 reactions that we're going to be looking at, these 4 types of redox reactions. Now, what part of the process here is identifying what redox reaction is happening. And they're all actually pretty easy to see once you get the hang of what you're looking for. For instance, combustion reaction. If you see carbon and hydrogen in 1 reactant and O2 is the other reactant, definitely combustion, all right? If you see 1 metal plus a non-metal gives you 1 thing, that's definitely combination. We're gonna go over all 4 of these reactions in the next video. It'll probably take 2 videos because single displacement does take a little bit of time to go